from a random number table, but do not look at the table. Just close the eyes and point one numbers, and let's assume this is number, because total is you have a 3 digits 750. I'll pick up the first 3 digits 0, 3, 7. Then 0, 3, 7 players is randomly selected, firstly selected person, and then you may go to next and next. One way is you can move to the right hand side, or diagonal direction, or jumping is randomly. You can choose it. Let's assume you move to right hand side. The first 3 digits is 447. Next selected person's ID number 447, and then you decide jump, and it is 189. Because every number is randomly generated. You can jump, it will be okay. If you do this, you will choose 10 persons, okay? You continue this number, and then you may go to this direction. It's okay. If you moved here, it's 038, and moved here 104, something like that. Randomly, you move to the any direction, right, left, up, down, or diagonal direction, and pick up first 3 digits. If first 3 digit is, for example, here, bigger than 750, and go to next number, you can skip it. Okay, for example, this is, so in this case, when you pick up this one and the next number, less than 750, then 718 will be okay. You can choose any number from random number table, but some of you may think of how random number table is generated. Okay, you may search in the internet. There is some story. One method is so I will insert some. I cannot. Okay, one way is for example, any numbers first. Okay, any number you need to choose very first time. Let's say if you just give any number, 5-digit numbers, and then that will be seed number, and then this number is many ways, and then if this is x1, next number is x1 square, and then square again, and take a square, and only the 5 digits from the left or from the right. It's up to you. You can take a square and then pick out 5 digits. Take square, another 5 digits, and so on. That's one way. Another one is take a square root. Take a square root and you pick up, right hand side, except it cannot be 0, 0, 0, 0. Okay, if you take a square, it will be very small and small. Okay, in that case, all leading 0, just ignore it and pick up several digits from the solution of a square root. That's one way. You can take a square or square root and pick up numbers randomly. It is called random number. Then you can prepare random number table. If you need random numbers, you don't need to take a square or take a square root. You can use random number table directly. Random number table is available. Another one is I will use my Excel file. Okay, this is page 248. 248. 248 is all this data is printed in our textbook up to 30 days. It says Jane and Joe Millie operate the Foxtrot Inns, a bed and breakfast in Tryon and North Carolina. There are 8 rooms available for rent at this B&B for each day of June 2019. The number of rooms rented is listed. This is number of rooms rented. Number of rentals. June is day 1 to day 30. Some day is nobody. Some 2 rooms, 3 rooms, sometimes 7 rooms, and so on. Okay, when they pick up, this is population, whole thing, whole number of rooms rented during June. This is a sample. This is population. Among them, they want to select 5 samples. 5 samples. Now textbook is 2480s. We pick up date 23, 4, 26, 14 is then 20. What is 20? 20 is 2. You want the 2 here. 3 is, day 3 is 3 rooms. Day 4, 2 rooms. Day 26, 4 rooms. Okay, day 14, 4 rooms. They want to create a random sample like that. Do you understand? This is a population. This is our sample. Because we cannot test all of them. Sample size n equal to 5. Okay. Population size capital N equals 30. You need to understand this one. But here is, if you want to calculate using this one, is one thing is, when 20 is, you can look at that, this one is 2. But when you use Excel, you don't need to do it. It is a VLOOKUP. Function name is VLOOKUP. Bracket. This is E12. E12 value is compared to P4 to P. I can't wait a minute. C33. Okay. C33, comma 1, 2. So I will explain. This value E12 will be compared to this table P4 to 33. All this number. And then if anything match, second column, this is, it means this is the first column, the C column is the second column. Okay. The second column will be returned. This is the second column. For example, in the 20 compared, when it's going down, 20 is here. If they found row 23, 20 is equal to E12, then second column is 2 will return here. When you make copy and paste, when you copy and paste, you need to use your mouse. Select this one and move your cursor to right lower corner. The thick plus will change the simple plus sign, and press your left button and drag down. Then before C23 with $sign will not change, because with $sign is called absolute reference. So the E12 is relative. This is relative. This is absolute. Okay. E12 E12 will change to E13, E14, E15, E16. Once you enter correctly, you don't, for example, you don't need to enter this one. At first time, I entered correctly, and then move your cursor to right lower corner, change the plus sign, and press your left button on your mouse and drag it down, and let it go. It counted. Number 3, third day is 3, correct. 4 is 2. 26 is 4. Okay, 14 is 4. You need to do is select this one. Pick up random numbers among 1 to 20, from 1 to 30. From 1 to 30, you pick up 5 numbers, 5 days, and corresponding rental number is automatically picked up by VLOOKUP Excel function. I don't know how many of you, do you know what is VLOOKUP? I have explained already, okay? So you need to know clearly about, here is $, $B, $4. B is absolute, 4 is absolute, colon, $C, $33. Okay, so use the function key F4. Relative references change to absolute reference. Okay, I will erase this one. I hope all of you do understand clearly about absolute VLOOKUP functions. Now, I want to pick up my own. This is textbook gives this number. Textbook gives this random numbers, but I want to choose my own. One way is 5 numbers. One way in Excel is R, A, N, D, rand, open bracket, closing bracket, hit enter. And then move here, right row, gonna copy and paste 5, pick up 5 numbers. You need to understand R, A, N, D, rand. Rand generated randomly between 0 and 1. Randomly selected, okay, it is a continuous probability between 0 and 1. Between 0 and 1, everybody has equal opportunity to be selected. So every number is maybe 0.578 is selected, 0.61, 0.60, 0.7, 0.24. When you change here, once it is selected, you can change this number. Okay, wait a minute. How to change the random numbers is you need to choose this one, and when you change, even copy and paste again, everything, all random numbers changes at the same time. At least one is changes, every 5 numbers will change at the same time. You can change. One changes, everything changes at the same time. That's rand, but rand function is generate R, A, N, D, open bracket, closing bracket. Between 0 and random numbers is generated. If you want random numbers between 1 and 30, also we want to integer. In that case, another function name is, look at here, rand between equal R, A, N, D between starting number, comma, ending number, bracket. Then the formula will be rand between 1 to 30. and then copy and paste. You have 5. So it changes automatically. Okay, changing all the time. Here, how many numbers I will use VLOOKUP this E5 compared to before to C33, and then if the matching number is found, second column will return. Okay, but I will try to change the number, copy. You see, when I do that, can you see some problem? Here 20 is duplicated. It pick up twice. Then it is not 5 samples. It is only 4 samples. In that case, all you need to do is select again until all 5, there's 25 is duplicated, then do it again. Oh, this is okay. 26, 11, 17, 5, 10. You need to continue until totally different 5 samples are selected. And when you change it, random number changes at the same time. Number of rentals rooms are also changed at the same time. That's random sampling, simple random sampling. So simple random sampling is every item has equal chance to be selected. So you need to use random number table, or you can use Excel random number generation. Or you can use rand. Rand is only between 0 and 1. Okay. If you want to use rand, it's complicated. So if you choose like this, you need to do more work is needed. For example, you use rand function, then all you need to do is equal to this number multiplied by 30, because June has 30 days, and then make copy. And it has all decimals, so you need to take round these numbers, ROUND, open bracket, close bracket. So to few, this means, and how many digits? Is it 0 will work? Okay, so truncated that all in decimal. See? So you is duplicated, okay? Then do it again. You change this one. And it's okay. If you want another one, change it until you have non-duplicated numbers. Okay, that's a simple random sampling, but I do not recommend just generate a decimal between 0 and 1, and then you need to multiply, and rounding is not a smart way. Smart way is you need to use random between function, bracket, starting number, comma, ending number, bracket. And number of rentals, you need to compare the randomly select number compared to population, and return second column. Second column is number of rentals. Okay? In that way, you may select your random sampling. With systematic sampling is I will try it. Systematic random sampling is if you do not have a list of entire population to begin, you can use the systematic random sampling is the step 1. Select a starting random number first, and then every case members will be selected systematically. So for example, should the grocery store want to start length of time customers spend in their stores? Randomly select. Then, okay, what day you want? Okay, let's do it today. Today, what time? Maybe 2 p.m. So we randomly select date and time, and starting point. We currently, let's just some 10 customers are there. So you close eyes and pick up very first customers to be tested is randomly. And then every fifth customers, or every sixth customers, or something like that. Every case member will be selected. Every case member is systematically. For example, here, look at the Excel. At beginning, I have chosen some numbers. So here, this one is, I use range between 1 to 30. Randomly select the first number. Randomly select. Total population is 30. I want to choose 5, so it's 6. So starting 27, 1 to 27, 28, 29, 30. This is the first one. And every six numbers we see here, 1, 2, 3, 4, 5. You need to continue like 1, 2, 3. 1, 2, 3, 4, 5, 6, every 6. This one, 3 is selected. So to do it, I will decide the next number is from previous number plus 6. The 10 is 27 plus 6 is 33. But we have only, June has us 30 days. So if number is less than 30 or equal to 30, that's okay. H5 plus 6 is correct. If it is bigger than that one, and I need to subtract 30. For example, is 33 is bigger than 30, and minus 30 is 3 will return. And then plus 6 is 9, plus 6, plus 6. Plus 6 is 27, is repeated. And number of renters is 27 is removed to 27 is 1. Okay? If I change this one, if I enter again, then 27 change to 17. 17 is 5. And then every 6, 26, 23, and plus 6 is 29, plus 6 is 35, minus 30 is 5. Add 6 again, like that. Random select very first one, and then I add every 6 members. Every 6 members is systematic. Systematic sampling is used. Okay. Any question about so far? Then I will go to next. Stratified random sampling. The population can be divided into groups. You need to divide into group first. Based on some characteristic, using stratified is group-wise. And so we have a lot of layer and so on. A population divided into subgroup. Subgroup is called strata. Strata is a sample is random selected from each stratum. For example, is a study of 50 out of 352 large U.S. firms and how much money is spent, what is total expenses, and so on. Among 352, we cannot do it. So they want total. This is capital N, the population size. 50 is sample size, small n. Then this is number of samples, small 50. And total number 352. So stratum is they divided, ROE, return on equity. Return on equity. ROE, return. So it means return on equity is how much net profit, how much they earn. divided by their equity. For example, two firms, A and B. A firm is earned $1 million. B earned $0.5 million. Which firm is better? Many people said A firm earns more, okay? But let's assume their equity is 0.5. This is a profit. In other words, earning. This is equity. Equity 0.5 million. And divided this one is ROE is 2, number 2. 1 divided by 0.5. But let's assume company B, equity is 0.1 million. 0.5 million divided by 0.1 is 5. Which firm is better? Company B shows a better performance. Their earning is 5 times more than equity. Company A is only 2 times more compared to their equity. So in that case, company B shows a better ROE. ROE is very important terminology to understand, company performance and so on. How much they earn. You need to understand what is ROE. So to test it, I want to sample 50. But when I tested, ROE is more than 30%, 20 to 30%, 10 to 20, 0 to 10, or minus. Then you test, we have 5 layers. 1, 2, 3, 4, 5. 5 subgroup, 5 stratum. Okay? And then investigate more than 30% is 8 companies. 20 to 60 is 35. 189 firms between 10 to 20. 115 is 0 to 10. 5 companies shows negative. Okay, so when you have such things, we want to pick up 50. So 8 divided by 352 is we have calculated relative frequency. 30 divided by 350. 189 divided by 352. After we calculate this one, and then this percentage multiplied by, for example, 0.02 multiplied by 50 is 1. 0.1 multiplied by 1 is 5. 0.54 times 50, and the round number is 27, 16, and 1. So number of samples for each group should be proportional to the population. Population itself has this percentage. Okay, sampling number also should be proportional to the same proportion. So 1 sample pick up from this group, 5 sample pick up from second group, 27 pick up from third group, 6 come from fourth group, 1 come from the fifth group. Then our sample will be more representative of the population compared to just simple random. A stratified random sample is quite often it is used. But next question is, then how can I choose this 5, 1, 5, 27, 16, 18 is we need to choose 1 sample out of 8 firms randomly. From here to there is we need to use simple random. Simple random sampling will be used. How about 5 out of 35? Again, simple random sampling will be used. Okay, if you use sample size for each different subgroups, and the relative frequency will be calculated based on population and then apply same relative frequency to sample size, then you will have a good representative samples of population. Stratified. Well, here in Excel, I cannot use any stratified. For example, is in this case, specific case is not appropriate because room is total 8. Okay, it's not appropriate to apply here. Next is I erase. Next, cluster sampling is a common type of sampling when it is used to reduce the cost of sampling over a large geographic area. For example, you want to test whole Cambodia, whole Korea, whole America. You cannot do that because geographic area is so large. In that case, population is divided into clusters using naturally occurring geographic or other boundaries. For example, this is Michigan State. Lake Michigan. I didn't live in the Michigan State, but they have some town. They have many towns. Okay, it's well divided in the cluster. So the cluster randomly selected, and then sample is collected randomly, selecting from each cluster. For example, Chicago has 12 counties. 12 counties in Greater Chicago area. They have 3 counties only. Okay, so close eyes. They will pick up 3. One is like this. Here, 3 one is Kenosha, Cook, LaForte, and they pick up 3 counties, and then pick up simple random samplings in each of 3 counties. Then it is cluster sampling. But how do you know when you pick up these 3 county will represent the whole Michigan? So that's why when you choose clusters, cluster selection should be random. 3 out of 12 counties, you need to choose 3 counties randomly. This is important thing. Randomly select 3 counties, and then you can apply simple random sampling. So far, we have studied 4 ones. The first one was simple random sampling. Simple random sampling, you can use random number table, or you can use Excel function. Second method is systematic. The first one is randomly selected, and then every case member will be selected. Stratified, you need to study whole population relative probability, and based on the relative frequency, you divide the sample size into each stratum, how many samples will be selected. From each stratum, when you selected samples, you need to use a simple random sampling again. Cluster is whole population is very, very large geographic area. And in that case, whole geographic area will be divided into cluster based on geographic or other boundaries. And then choose, randomly select, 2, 3, 4, it depends on. You need to decide how many counties will be studied. And from within each counties, you need to apply simple random sampling. We have studied 4 methods has been studied. Next is what is sampling error. Sampling error is, let's go to next. The sampling error means it is unlikely the mean of a sample will be exactly equal. For example, is our population is huge, very like capital N is large. Mu, sometimes we do not know, sometimes we know. And selected samples, x1, x2, up to small xn. And we have calculated x bar, right? Mean of a sample in the x bar, okay? Mean of population is mu. You need to distinguish them clearly. Sample mean, population mean is different. Okay, here, population mean is mu. Mean of samples is x bar. It will be exactly equal to, is unlikely. Maybe, but it's a very special case. In most cases, it will be different. The difference between sample statistics is x bar minus mu. Okay, the corresponding population parameter mu is population parameter example is a sampling error. Population parameter Foxtrot is number of rooms rented in June, right? And the mean of the room is mu. When you calculate all 30 days, 3.13. For example, 3.13. So here you need to use average of everybody. 3.133. 3.13. Sample statistics, for example, is taking 3 random samples of size 5, and we will find the sample mean is here's size 5 means small n. Sample size is 5. And how many? 3 samples. For example, so it depends on, you can choose any number, okay? For example, if I choose this one, 1, 11, 12, 0 plus 3 plus 3, 6 divided by 3 is average is 2. If I choose this and this and this, 2 plus 4 plus 2 is 8. 8 divided by 3 is 2 point, right? 6, 7. You can continue that. If you choose this one, 4 plus 6 plus 3 is 13 divided by 3 is 4 point something. So when you choose this plus this plus this, okay, sometimes very low, sometimes very large. The sampling error is difference between x bar. X bar is sample mean. Mu is population mean. Okay, population mean is one example of population parameter. Sample mean is one case of sample statistic. Now, how can we determine how accurate the sample mean is? Our sample mean, if mu is unknown, we will estimate based on x bar. So accuracy of sample mean is our concern. Then sample mean, you need to read carefully. Sample mean x bar. What is distribution of x bar? Probability distribution, all possible sample mean of a given sample size. So what is E x bar? Our textbook says mu x bar. Okay, but I use E is expected value. So I will do I will delete everything. Okay. by mistake, when I save it, all my handwriting ink note will be saved at the same time. To prevent such a mistake, it's better for me to erase it. Okay. To be let's say we have this population. Mu is, sometimes we do not know. I have samples size of n, and I have surpassed the sample mean. If I sample again, another sample, second sample mean x2 bar, third one x3 bar, x4 bar. If I repeated this one, average of x bar, average of x bar, ex bar, or in average x bar, you can use 2 double bar. Okay, x double bar means average of x bar. Okay, if I repeat and like this, what will happen to the distribution of this? What kind of, it will follow a kind of normal distribution, average of this one. Okay, if you do it again and again and again, average x bar average will be equal to mu. So it will go to mu. X bar and mu is not equal, but average of x bar will be equal to mu. You need to understand, if you repeat and repeat, ex bar will be equal to mu. So x bar will be equal to population mean. You need to understand this sentence, what it means for. Okay, if you sample again and again, calculate x bar again, x bar again, x bar again, and so on, then x bar average means of all means average of x bar, the ex bar. Another one is average x bar, and you make another bar, x double bar. It will be equal to population mean mu. And it will be x bar. One x bar is not equal to mu because of sampling error. But x bar is not very far from mu. It's close, sometimes close. Okay, a small difference. So x bar 1, x itself is x1, x2 is very far, but first sample mean, second sample mean, third sample mean is not equal each other, but they are close. X bar 1, x2 bar, x3 bar will be not equal, but will be close. So it means less variation in distribution of sample mean than the population. So original x will follow in population in normal distribution, for example, n, average mu, and standard deviation. But if you, what is a distribution of x bar sample mean? Sample mean will follow normal distribution, average mu. X double bar is equal to mu. But here, sigma square x bar. When I say here sigma square is equal to sigma square, sigma x, original x, variance, standard deviation x. Here is x bar, it's different. This sigma x bar square, sigma x square, which is this is much smaller than that. The variance of sample mean is small, is less variation. And sampling distribution of a sample mean tends to become bell-shaped. Bell-shaped means it will follow normal. Okay. This is very important concept. You can learn based on your some example. Example is Tata's industry has 7 production employees, 7 people. Hourly earning for each employee. Because when you see this one, Ted is $18 per hour, is maybe experience. Joe, Sam, and Jane is maybe it's not experienced. Recently hired. Okay, their hourly wage is $14. The others are $16. So they have 7 people. 7, and they have 7, and they want to choose sample size of 2. What is it? I have prepared this one is this. Okay, this is what it. He wants to choose 2 samples. The total capital N. Capital N is 7. Sample size small n is 2. Now he wants to choose 2. One thing is this is a kind of employee number 1, 2, 3, 4, 5, 6, 7. Instead of a name, I just use number. Then 1 and 2 is selected. 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7, or 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 3 and 4, 3 and 5, and something like that. So we how many different combinations? And 7 people. Out of 7, I will choose 2 person. How many different combinations? 7 factorial. 5, 4, 3, 2, 1. Divided by 2 factorial. 2 times 1. 7 minus 2 is 5 factorial. 5, 4, 3, 2, 1. Then this and this canceling out. Then the 2 divided by 3, 21 combination. Okay, here, starting here, 1, 2, 3. When you add up, is up to 2, and 23 minus 2 is 20. 23 minus 2 is 21. The total 21 combination. Okay, then I will try to use what is their salary per hour. So if it is 1, this compared here, 1 compared. Okay, so if we look up F3 compared to all this one, A2 to C8, and then it's matching. Third column 1, 2, third column will return. This number is again C3 is compared to A to C8, and third column return, and 1 is 14, 2, 14, with 1 and 6. 1 and 6 is 1 and 6, 1 and 14, 6 is 16. I just use everything in VLOOKUP, and then I have calculated average of these 2. You see, here, what is mu? Is population mean is average is just, calculate average of all the numbers. Here, average function name is average. Bracket. This is mu. Sorry. Average is 15.4. See, this is mu. This is mu. Population average. This is X bar 1. First the sample mean. This is X2 bar. we will continue. The last one is we have 21 samples. So this is X3 bar. If you repeat and repeat, I will test it. I try to get this. Minimum is mean. Minimum of J column, J3 to J23. Maximum is so 14, 15, 16, 17. And then I counted how many are there. So is count if J, I have counted all these columns up to here. Okay, equal to N6. N6 is 14. Count if of this range, if that is equal to N6, 14, 3. And here, this is absolute reference, and N6 is relative, and next time is N6 will be N7, N8, N9 is counted, total 21. 3 divided by 21 is equal to just divided by. Okay, then its relative frequency is calculated. You can calculate, you know, this one. See, sampling distribution we have calculated. I have 15.43. This number, 15.43. 15.43. So what is population mean? I have calculated. What is sampling distribution is when I do this one. I have calculated for you already. I have calculated this. And why it is sampling mean distribution? Sampling mean distribution. And you see, and then I will draw, for example, is try to insert chart. See, when you use percentage small difference of 3, they draw the column wise, so it's better to change the format. Okay, so when you look at here, this is X bar 1, X bar 2, X bar 3, and so on. I will try to calculate the average of, I will try to average, okay. Here, equal, average of sample mean, average sample mean is average of this one. 15.43, exactly same. Or you can use sample mean here, sum product. Sum product of this multiply its frequency. The result is exactly the same, 15.43. But standard deviation of this one here, look at here, average is okay. Wait a minute. Here, I will use standard deviation equal to STDEV. But because this is population, I need to choose .P must be used. Click this one. Population standard deviation 1.399. Here is average sample mean and standard deviation of sample mean. Standard deviation of sample mean, not sample. So STDEV is everything is, you can use .P. I will try to use this one because see when you hear standard deviation originally the standard deviation 1.39, almost 1.4, but it's much narrower. Right. So here is when you do it, it will be less. It is less variation. So I have explained when x followed normal distribution mu and sigma square, x bar will follow normal distribution mu is same. Average, because average of x is x double bar and mu is exactly the same. But here, sigma x bar square, this and this is not, which is sigma x bar square is smaller than, this is smaller than original variance. We have calculated here is standard deviation becomes smaller. You have calculated, and then it becomes narrow. What observation can be made about population sampling distribution? This is mu. Here, mu is population mean. This is sample mean, x bar average. But I like to, because mu is a little bit complicated, or x double bar. Our textbook uses this notation. Okay. Spread in the distribution of sample mean is less the spread means standard deviation. Standard deviation of sample mean is less than standard deviation of population mean. So originally like this, but when you calculated the sampling x bar will distributed. Here is the right bar chart shows this one. Original one is different, you know. The graph is original population is like that, but sample mean is like that. So when you see the maximum minimum is a little bit wide, but it's narrow. Okay, and we have calculated based on these cases. Central limit theorem is if samples of a particular size are selected from population, random population, sampling distribution or sample mean is approximately, it will follow, important word is approximately normal. Sampling mean, x bar will follow normal distribution, even though original x is not following normal distribution. For example, here, if population follow normal distribution, then any sample size, n doesn't care, any sample size will show normal distribution. If population is symmetric, but it is not normal, but symmetric, then it will be normal shape of distribution sample mean emerge with samples as smaller as 10. Okay, but if distribution is skewed to the left or right, and thick tails means it has like this high peak and low peak and so on. It may require more than 30 or more to observe normality. So if originally, so I will show you next slide. The population itself, look at here. All these four cases, these are not normally distributed, but the population. Sampling size is n equal 2, 6, 30, and so on. As n increases, x bar will follow normal distribution. That's the key. Whatever, even though population does not follow normal distribution, okay, x bar will follow normal distribution if n is large enough. And n is small. When you look at it, left and right is very big, but you see n is 2 is close to normal. And then 6 symmetric, and n is 30 very symmetric with a narrow spread. So central limit theorem is whatever whatever probability distribution followed by x bar, sample mean will follow normal distribution table. But population is normal, then sample size, small sample size is enough. If population is not normally distributed, skewed, thick, and you need more sample sizes needed. See, this is very important for chapter 8. Most important thing is this: sample mean will be equal to population mean. Okay, average x bar, x double bar will equal to mu, and it's exactly equal to population mean. But here, look at here, sampling sample mean spread, the sampling standard error will be smaller and smaller as n increases. What happens? Sigma x bar will close to 0. N is a very large denominator. Sigma x bar, standard error of the mean will be 0. So standard deviation, sigma is population standard deviation divided by square root n will be sigma of x bar, standard deviation of sample mean. Another word is standard error of sample mean. Okay, there will be less dispersion. So n is bigger and bigger, and it will be less dispersion is available. Okay, then we have two more. Okay, I have two more slides and then take a break. Normal distribution. If population follows normal distribution, then sampling distribution of sample mean will also follow normal distribution to any size. If population is not normally distributed, if population is following second population not sampling in distribution x bar will follow normal because of some central limit theorem, but we need a sample size at least 30. Okay, and once you have normally distributed x bar, will follow a kind of normal. So in other words, when x follows normal distribution mu and sigma square, then sample mean will follow normal distribution average mu, standard deviation sigma square divided by n. You need to understand. So this is sigma x bar square. Okay, so it will be exactly the same as this. When you take a square, sigma x bar square is equal to sigma square divided by n. Standard deviation should be divided by square root n. And then you can use standard normal distribution table after transformation. You can jet formation. You can use it. Example is Quality Assurance Department cola incorporation maintain record regarding to amount of cola in jumbo bottle. The actual amount of cola in each bottle varies a small amount of one bottle to another. Records indicate that amounts of cola follow normal distribution. Based on our historical data, original population will follow normal distribution. This is a good sign because we can use a small sample size. Mean amount of cola in the bottle is 31. This is X. X will follow normal distribution. Average is 31.2. Standard deviation, comma, 0.4 square ounce. That's population. At 8 a.m. today, quality technician randomly selected 16 bottles. Pick up and sample size is 16. the amount X bar was 31.38. It is an unlikely result. Is it likely the process is putting too much? Then average 31.38. Population targeted 31.2. It looked like a little bit, add a little bit more, 0.18 ounce. 0.18 more ounce is added into the bottle. So quality manager want to know our process is okay or our process is something wrong and so on. Whether we put too much soda in the bottle. Sampling error is, we calculate it like that. 31.38 minus average, right? Because X bar will follow normal distribution average 31.2. Okay? Getting 0.4 divided by square root 16 square. This is, so we need to use this one because we need to be using sample mean rather than X itself. 1.8. 1.8 is here. 1.8. When you use normal distribution table, this red area is area 0.4641. The right half is 0.5. So 0.5 minus 0.4641 equal to this. So 1 point, you see, 31.38 is equivalent to Z equal 1.8. If it is outside of this, it looks like this over bottles. This is less bottles. If it is, we conclude that it is likely there is less than 40. This is less than 0.0359 is less than 0.04. Okay, so the process is putting too much soda in bottle is, so it depends on how many percentage, but we cannot conclude directly. Okay, so when you calculate this one, and then you may realize, oh, 31.38 equivalent to Z equal 1.8. 1.8 is you see, this is about less than 4%. So it means, what it means for, sorry, by mistake, okay, yeah. Okay, when you have this one, and then next, all you need to do is, .8 is serious. Well, it depends on your what percentage you like. You may conclude it is unlikely, or you may conclude that is likely. It depends on how many percent chance you prefer. It's 4% chance. So 4% out of 100. If you allow 4% out of 100. So it means when you process 100 bottles, 4 bottles is overfilled. If you allow that, then it will be likely. If you cannot accept this is too much, then it will be unlikely. It depends on percentage, whether you accept this percentage as allowance. Okay, we will take a break here, and then 15 minutes later, I will try to solve a problem. Okay, please come back to classroom after 15 minutes, no later than. Okay, see you.